Hi friends, now let's continue our discussion on deletion of a node from a doubly linked list. Previous session we have seen how to delete the head node or a node prior to a node whose key is given. Now let us check how to delete a node after a node whose key is given to us. So here this the key given is 2, so we need to delete the node which comes after this particular node. So that means we need to delete a node having a value 3 in this case, because key given is 2, so we are trying to delete a node after the node which we know. So the logic is we start from the head, we start moving forward till we reach the key element. So first node we check that key is 2, no, then we go to the next one, key is 2, yes, we got it. So this will be called the current node. Then we go to the next node, call it the node to be deleted. And then what we have to do is current nodes next should be the next of the node to be deleted. So next of the node to be deleted is this node. So we need to create this link. Same way, so next of the nodes to be deleted previous should be the current node. So if we make these two arrangements, and then we are free to delete the memory allocated for this. But to make sure that which to be deleted, we need to save this. So we just save this as a temporary and then continue our process. Let's look at the code. So we begin giving data as where the head is and what is the key we are looking for. So to traverse through the doubly linked list, we begin from the head. So we make use of a pointer current and just keep moving. If the current is not null, then look at it. If the data in the current is it key. So this current, we begin with the head. So this is not null, yes. Then we go in and see is it equal to key, no. If no, then go to the next one. If yes, stop there. So we are looking for key equal to 2. So we begin from the head. So is this equal to key? No. Then go to the next. Is it equal to key? Yes. Break. So when we break, the node called current is the node having value equal to 2 in our example. Once we have done that, then we just check is this node is null, or if the currents next is null. If the currents next is null means this will be the last node, therefore we don't find any next node. Therefore in this case we just return the head, can't do anything. Then the node to be deleted will be the current nodes next. So current node is this, its next will be this which we want to delete. So we remember the address of that so that in future we can delete the memory allocated to that, free the memory. Then the currents next. So this is currents next is this one, which is that node to be deleted next. So node to be deleted next is this. So we want to connect this connection. So currents next is equal to this. So this lower arrow is connected, and node to be deleted next. If it is not null, that means this exists, then only I can make this reverse connection. Then node to be deleted next. Node to be deleted is this, its next is this, and its previous means this. I point to the current node. So I make the upper path and then free this node and then finally return the head. So let's check the code. So now we are working for the one which talks about what is next. So this how the node is defined. So delete after, and so keep moving till we reach the node. Once we get that, break it, otherwise keep moving further, and then remember the node to be deleted as the current node's next one, and then current node's next will be node to delete next, and then make the reverse connection and free the memory allocated for that node and return. So create a linked list 1 followed by 2 followed by 3 followed by 4, and then finally we delete after 2. So 1, 2, 3, 4 are the sequence. After 2 we are deleting, that means 3 is deleted. So what we are left with is 1, 2 and 4. Just let's check what we get. So 1, 2, 3, 4 were there. So after 2 we are deleting, so 3 gets deleted, so we are left with 1, 2 and 4. So let's check any other way. So instead of after 2, if we delete after 1, then 1, 2, 3, 4, after 1 should be deleted, that means 2 should not be there, so 1, 3 and 4 should be the answer. So after 1, 2 was there, the node 2 gets deleted. So now we have 1, 3, 4. So that's all about what we call deleting before after the given node. Now the next is deleting at a specific position. So in this case, position given is 2. So the second position. So what we have to do is we need to begin from the head, keep track of the position. So have a counter and keep counting 1, 2, 3, 4 and so on. And the moment we reach that node whose position we want to delete, then go back one step and go further one step and use these two nodes and make the necessary connections. So the thing says that start from the current node and then keep the position I, start with 1 until we reach end of it, or till I is less than the position, keep incrementing. Then at every loop just keep moving one step further. So if we say position 2, then this is 1, then this is 2. At 2 we have to stop. If that is null, then we just have to return head, and if that previous is not null, so we want this node. So its previous is not null, means this is not the first node. Then current's previous next will be the current's next. So this is current's previous next. So we are making this particular thing link, and then if currents next is not null, that means this is not the last node, then we need to make this connection and say that currents next is this, its previous is currents previous. And if the head is current, then head will be currents next, because if this itself you are trying to remove, then this is removed, then this should become head, and then free the current and return the head. So let's check the code for that. The position, so here we have that code we have just discussed, and the example is 1, 2, 3 are the three links created. So in this case we are defining 10, 20, 30 as the three nodes with the values, and then before deletion we are just showing the head, the list, and then after deleting which one to delete. So position number 2 is deleted, then we should be having 1 and 3 only, 2 should be deleted, that means we should have 10 followed by 30. Let us check, do we have that? So 10, 20, 30. So the second one we deleted, so 10 followed by 30. So what if we delete the first node? What if we delete the first node? That is equivalent to saying delete the head. So we are left with 20 and 30. And what if we delete the third node? It is equivalent to saying delete the last node. So we are left with 10 and 20. So that is what we are talking about. So the last one is deleting the end of the doubly linked list. So to delete the end of that, what we have to do? So from the head, keep moving till the end, and when you go to the end, go one step back. So save this in a temporary variable pointer, and then go one step back and call its next as null, and then delete the memory allocated for this. So that's a simple thing we need to do. So if you don't have anything, just return null. If we have heads next is null, that means we have only one node, then there is just free the head. Then otherwise we have some linked list, because heads next is not null means there is at least one next node. So start with moving ahead. So we define a pointer called current, and currently we begin with the head, and then we start moving further till we don't reach the end. So while currents next is not null, just keep moving, current is currents next, current is currents next. So keep moving till you reach the end. Once we reach the end, then currents currents previous next. Currents previous is this node, its next is made null. So this is done. Now we are free to release memory allocated for this. So that's a simple logic we have for deleting the last node. So let's check what is that logic. So Keep moving ahead till you reach the end. Once you reach the end, currents previous next is null. Then free the current, return the head. So we have created a doubly linked list 1, 2, 3, and then delete the last one. So we should have 1 and 2 only. So let's verify what we get. So 1, 2, 3 were the things. Now we are left with only 1 and 2. So that's what we have for the deletion. So we have seen deleting a node which is ahead, deleting a node before any given node, or deleting a node after any given node, or deleting a node at any current position, and finally we are seeing how to delete the last node. So that's all about how to delete a node from a doubly linked list. Other details about the doubly linked list to be followed. So keep watching. Thank you.